Now I'm going to show you how to solve equations and inequalities involving absolute values. So I'm going to start off by a property, and then I'm going to do some examples, and I'm going this way, property and example, so I can show you all that there is to it. So the first property, imagine that we have the absolute value of a variable equal k. K is a positive number. Doesn't matter if it's an integer or a real number, doesn't matter. So is this actually is equivalent to x equal minus k, or x equal k, where k is a positive number. Now, as an example, we can take a few examples to just show how we solve an equation that has an absolute value. So let me just take an example, just a simple example. So imagine I have x, the absolute value of x equal 1. Now, in this case, the solution set that we said we refer to as S just simply equal 1 minus 1. Then another example, just a similar example, x equal, I don't know, minus 10. Obviously, x in this case equal minus 10, minus 10, which is 10, or minus 10, obviously, itself. And the solution set is 10 and minus 10. Suppose I have a sort of algebraic expression. The absolute value is of an algebraic expression, such as this one: x plus 2 equal 5. Now, in this case, we just simply follow the rule. We suppose that this is actually the variable we're actually looking for. This is the x that we refer to in the property. So we just simply, let me just add a line here. Yeah, as I told you, in that example, we just solve what's in between the absolute value. So in this case, x plus 2 equal 5, or x plus 2 equal minus 5. And we actually, now this is just the first degree equation at this moment, and we just get x equal 7, or x equal, here just simply, no, I made a mistake here. It's not 7, it's, now we subtract minus 2 here, minus 2, so it's obviously a 3 here. So sorry here, and here it's minus 7. Yep, very simple. Then we move to, now the second property is that of inequality. So let me just write a property 2. And Here in this property, if we have the absolute value of x less than, can be less or equal, yeah. So, yeah, less than k is equivalent to x greater than minus k, and you should really underline this and, because it's really important, and we're going to see another property where we have or, and this actually plays a difference when it comes to actually determining the the solution set. So, as I said, and x is smaller than k, where k is obviously a positive number. Now, to take some examples, as we did in the previous property, so it's pretty much the same. You just follow the property and you get the solution just simply. So the first example is the absolute value of x less than 5. Now, if we follow the property, we actually get x is greater than minus 5 and x is actually smaller or less than 5. Now we can actually sort of group these values. So we just simply get x is actually in between minus 5 and 5. And you can actually see the solution set now. If we just write it in terms of a set builder, we actually get x such that x is greater than minus 5 and less than 5. Just quite simply as that. But we're going just to write it, the set this time as an interval notation, so just to show you. So yeah, it's going to be minus 5 and 5, and you notice that the interval is actually open. If we have a sort of algebraic expression between inside an absolute value, we just follow the example we did when we solved for the first property. So let me just take that example just to show you. So we had x plus 2 less than 5. So we get x plus 2 greater than minus 5, and x plus 2 less than 5. So we just keep solving just in terms of just in any other inequality, and we get pretty much the same values as we did for the equation. So it's x is greater than minus 5 and x is smaller than 3, and that's actually, we find that x is actually between the interval is between minus 7 and 3. So that's what we have for the second property. Now I'm going to show you the third And the last one. The last property I want to show you is that imagine we have a variable x. This time it's greater than k, which is obviously a positive number. Now, all this is equivalent to x less than minus k, or x greater than k, where k is a positive number. Just to take a simple example, let's suppose we have I don't know, just a simple one. The absolute value of x is greater than 2. Now here obviously we have, according to the property, x is less than minus 2, or x is greater than 2. Now as you can see, we actually here in the property we have or as opposite to and, which we had in the previous property. Now this is going to be different because you will see in the we have two separate interval. X is less than minus 2, or x is greater than 2. So yeah, we will actually use a symbol called union of sets, because we have two sets or two intervals, and we're not really sure where x is. Is it less than minus 2, or is it greater than 2? We don't know. But the solution set is written something like this. Minus infinity, minus 2, and yeah, this is the union sets. It's like a U symbol, and voila. And yeah, this is all we have for this video.